What's going on, my friends? Happy Friday. You should all be watching this on Friday, May 1st. Today is Thursday, April 30th. It's such a dreary and gloomy day. It's rainy. So I don't know what you guys are doing on a rainy day. I know a lot of you are inside anyway, just like me. But if you're doing anything cool, if you're watching any cool movies, any shows, any YouTube channels, any books, I want you to send me a private comment in Google Classroom. That'll let me know some maybe cool ideas that I can do. And then it'll also let me know that you're tuning into these videos. All right, my friends, on the docket today, we are doing lesson 13 in Zearn. And the name of that lesson is Name That Triangle. And based on the title, we can all assume that we're working heavily with triangles today. We did it a little bit at the beginning of the unit. We're going to get back into it now. In order to be on 13, like always, you need to have completed lessons 1 through 12. We skipped 11, so you guys lucked out there. Don't worry about that. All right, let's kick it off with 13. We'll read the objective together. Students will be able to analyze and classify triangles based on side length, angle measure, or both. Okay? Now, we've already talked about angle measure. All right, we talked about right angles, obtuse angles, and acute angles. So keep those locked into your memory. We're going to review those a little bit, and we're going to introduce some new terms today that help us classify triangles based on their side lengths. Like always, before we really get into the math chat, I want you guys to complete your fluency activities, and then you should already have your Dreambox work done for today. A lot of my friends are doing a great job in Dreambox. Again, there's a handful of us that I want to be working on that every single time you start an assignment. It's a great review, and it also introduces some really cool math and fun ways to do the math. All right, let's kick it off with our math chat.
What's up, Math Riddler? What has 3 sides and lots of symmetry? Your first problem.
All right, I'm sure we're all familiar with triangles. Let's call this triangle A. We'll name it with a letter, and we'll label it with that letter. Here's our A. Does this triangle have any lines of symmetry? Well, here's a quick review. Remember, a line of symmetry, if I have a shape, it divides the shape so that if it's folded on top of itself, it'll match. So can I draw a line of symmetry in my triangle here anywhere where if I folded it over that line, it would match? I want you to go ahead, and I think it can. I think we do have some lines of symmetry. I want you to go ahead and answer this question here. All right, mark all the lines of symmetry. You can pause the video now and then check your work afterwards. All right, if you were having a little bit of trouble, just remember, in order to draw lines, you have to connect your points. So I see one line of symmetry here at the top vertex, the very top angle, and at the base, right in the middle of our base. The base is the bottom line here. There's one line of symmetry. If I folded that on top of, over that line of symmetry, it would perfectly match the other side. So if I can do it here, it looks like all my sides are the same length. I can probably do it here and to our bottom right hand angle, and then on the right side length and to our bottom left hand angle. All right, how many lines of symmetry did I just draw? Boom, 3. Nice work. Let's call this triangle B and label it with a B. Here's our B. Does triangle B have any lines of symmetry? Pause the video now before you answer. I want you to tell me, does it have lines of symmetry? And how many lines of symmetry does it have? You can use your finger. You can try and recreate this on a piece of paper. But I want you to go to Google Classroom and answer that in a private message now. Okay, you're back. There is at least one line of symmetry, so let's click yes here. And now we have to mark the lines of symmetry. Well, before we marked the line of symmetry here and here, these 2 points. But look at this. if I look at the two sides on either side of this line of symmetry, if I folded this over, I don't think it would land perfectly here, right? It juts out a little bit. The angle's slightly, it looks like slightly smaller. So I don't think that'll work. It looks like right down the middle is a nice, straight, clear line of symmetry where I can fold it over top and it matches. Great job. So we have one line of symmetry. I'm excited to see who got that one correct. Let's call this triangle C and label it with a C. Here's our C. That's the name of it. Does triangle C have any lines of symmetry? I want you to tell me in Google Classroom, does triangle C have any lines of symmetry? You can pause the video now. All right, my friends, you are back. So it looks like this is a funky triangle here, right? I don't know if anything really matches. I don't see any lines of symmetry. Let's go ahead and click no. Great job. No lines of symmetry.
Show me the symmetry, Lucas.
You can fold triangle A in half at any of its angles, and it's symmetric. So it has 3 lines of symmetry. Triangle B only has 1 line of symmetry, right here. If you tried to fold it in half anywhere else, it wouldn't match. And triangle C doesn't have any lines of symmetry.
Love it. Let's look at the side lengths of these triangles. To show that certain sides are the same length, we can draw a tick mark on each same length segment like this.
All right, my friends, this is the key concept whenever we're working with lines and in geometry. If side lengths are the same, if they are equivalent, you can mark it by drawing a tick mark just like this, right in the middle of the side or close to the middle. You just want to put a little tick mark just like they have here. It's the same color. Sometimes I like to do it in a different color if you have that option. If not, that's okay. It doesn't really matter. Okay. I think I maybe gave away a little hint on the next problem. So hopefully my friends were paying attention. But those tick marks will tell you if side lengths are the same. Let's keep moving.
Triangle A has 3 sides of equal length, and triangle B has 2 sides of equal length. Triangle C has 3 sides of different measure, so it doesn't get any tick marks. Now, let's think about that symmetry again.
Remember, no tick marks on C because there are no sides that are the same length. Okay, think about the differences between triangle A, B, and C in terms of side lengths and symmetry. What do you notice? I want you to answer in at least one complete sentence. What do you notice about side lengths and lines of symmetry in these 3 triangles? Head over to Google Classroom and tell me your thoughts in at least one sentence. I'll see you in a second. All right, my friends, you are back. Let's go examine the side lengths and lines of symmetry.
What do you think's going on, Sophie?
Well, triangle A has 3 equal sides and 3 lines of symmetry. And triangle C has 3 different side lengths and no lines of symmetry.
Great observations. Also, notice that triangle B has 2 sides that are equal, but only 1 line of symmetry. What else do we know about triangles?
All right. What do all triangles have? How many? How about only some triangles? Okay, so we have 3 different triangles here. We want to categorize them based on some different characteristics here. Okay, so let's drop and drag a few of these. I want you to try this on your own. Remember, if you think that 3 angles applies to all triangles, put it here. If you think only some triangles have 3 angles, put it here. I want you to tell me what your answers are. Press enter, and then we can check our work together. All right, my friends, it looks like all triangles, because they have 3 sides, we're going to put 3 sides right here. And if shapes have 3 sides, that means they must have 3 angles. All triangles have 3 sides and 3 angles. We can see the angles here. And we can see the sides surrounding our shape or creating our shape. All right, next, obtuse angles. Do all triangles have obtuse angles? Well, let's talk about obtuse angles. When we think about obtuse angles, we have to think about, we always start with an angle that's 90 degrees. That's a right angle. Now, anytime a triangle has a right angle, it's just one, okay? If it has one right angle, we call that a right triangle. Say it with me, a right triangle. Okay? Anytime an angle has one angle that's larger than 90 degrees, not the prettiest triangle in the world, but we can see that this angle opens up larger than 90 degrees. That's called an obtuse angle, and we can call that an obtuse triangle. Obtuse. So if obtuse opens larger than 90 degrees, then if we have three angles that are less than 90 degrees, and we'll say that these are all less than 90 degrees, that is an acute triangle. So acute triangles have three angles that are all acute. Right triangles have at least one right angle, and obtuse triangles have at least one angle that's larger than a right angle or larger than 90 degrees. So we can see only some triangles have obtuse angles. Others have right and others are all acute. And then only some angles have lines of symmetry. And we know that because if we get a triangle like C, we can see that there are no lines of symmetry here. All right, nice work, my friends. Let's see if we're correct. Good job. Let's move on.
Lucas.
I know all triangles have three sides, and they also have three angles.
Triangles can also have different types of angles, like acute, obtuse, or right. But only some triangles have obtuse angles, and some have lines of symmetry, but others don't.
Nailed it. Let's think about side lengths as we do this next one.
All right, y'all. They're going to want us to use this note page. Don't worry about it. We're going to use the note page on Zearn. And if you want to have a piece of scrap paper or your notebook that you've been using, that's totally fine too. And it actually might be good. I think that writing some of these definitions down now will really, really help you on your exit ticket. On your exit ticket today, you're going to have to do a good job defining what a couple triangles are classified as. So having that information on hand will be very helpful. You can always come back to the video, right? But then you'll have to scroll around and find the right answer. If you have it written in front of you, it'll be much easier to access. Our question: sort triangles A to F into groups based on how many equal sides each triangle has. Triangle A has been done for you. So we have 6 triangles here, A through F, and we want to classify them in this chart here. All right, we know they're all triangles because they have 3 sides and 3 angles. So our first classification, and what you guys are going to want to do is create this chart on your scrap paper. So what I would do is I would draw a rectangle just like this. I would split it in half horizontally, and then I would draw 1, 2, 3, 4 columns. I would make it look just like this, okay? So you can put your triangles here, just write triangles. I'll just write TRI. And then here you're going to have 3 equal sides. You're going to have 2 equal sides and 0 equal sides. And then we're going to fill this in with which triangles match. So which triangles have 3 equal sides? Well, we can visualize it, or we can look at our tick marks. Remember, tick marks tells us if sides are equal. It looks like A is the only triangle with 3 tick marks with 3 equal sides. So let's put that in. And they already did it for us. Once I'm done with it, I'm going to cross it out. All right, let's look at B. It looks like B has 2 tick marks. That means it has 2 equal sides. I'm going to put B in the second chart. I'll do it on both. Then we'll cross it out. We've already used it. Let's look at C. There are no tick marks here, and I can tell it's a little awkwardly shaped. So that means there are no equal sides. Let's put a C. Let's put C there for that triangle. 3 more. All right, let's look at D. So D, it looks like it might be a right angle, but we're not talking about angles here. We're talking about side lengths. And I can see the this diagonal side, this horizontal, and this vertical side are all different lengths. So D goes right next to C. I'll separate it with a comma. All right, we're done D. Two more. Let's look at E. Again, it looks like we have another right triangle, just like D, but this time our right triangle has two equal side lengths. I can tell by the hash marks, by the tick marks here. So E goes into the second box, two equal sides. And last but not least, we have F. It looks like F has two hash marks here. There's F. Okay. Now this angle here is a little different. I don't see any right angles, right? We're only classifying by sides, but I always keep my angles in mind just so I can start to, categorize these triangles and shapes into certain places. It'll help with organization. All right, our chart's finished here. Let's see if we're correct.
Hit me with it.
Triangles B, E, and F each had two sides that were the same length. And triangles C and D both had sides that all measured different lengths.
A is the only triangle where all three sides all have the same length.
I love it. There are three kinds of triangles you discovered here. Equilateral triangles, like triangle A, have three sides that are equal in length.
This is our first type of triangle that we can classify based on the number of equal sides. So when you're talking about triangles and sides, if you have three equal sides on your triangle, that's an equilateral triangle. Say it with me, equilateral triangle. And the real tip here is equal, right? Now it's not spelled like we spell equal, but we pronounce it as equal sides. All right, let's keep moving.
That's easy to remember because the beginning of equilateral sounds like equal.
That's right. You also found some isosceles triangles, like B, E, and F, which have at least two sides with the same length.
All right, so this is a new word here. It's a new way to classify a type of triangle. When we're talking about sides, if it has two equal sides, a triangle with two equal sides that are the same length, it should have two tick marks, okay? And we call it an isosceles triangle. Say it with me, isosceles triangle. You sort of pronounce it like an eyeball. Isosceles triangle. Say it one more time, isosceles triangle. And the cool thing about these triangles are that you can always fold them. If there's only two equal sides, you could always fold them over the middle, that line of symmetry, and they'll match on both sides, okay? And that tells us a few different things. One really cool thing it tells us is that if these two sides match, then the bottom angles also match. These angles will be the same. These angles will be the same. And it's flipped upside down, but these angles will be the same. Okay? So two equal angles and two equal sides. And then for those, there's only one line of symmetry. You might be asked this question on your exit ticket. Make sure you're paying close attention. So right now we have an equilateral triangle, three equal sides, and an isosceles triangle, two equal sides. I would have those written in your notes. And let's learn about the third classification of triangles.
And triangles C and D are called scalene triangles. None of their side lengths are the same.
Okay, scalene, sort of like scales, right? Scalene triangles. Say it with me, scalene triangles. Now, for these ones, you won't see any tick marks because all the sides are different lengths. There are no equal sides. And that's our third type of triangle. Equilateral, isosceles, and scalene. Lock these three into your memory. We're going to use them a lot. Oh, and I'll send out word on Monday, but we're going to do a little quiz next Friday. So there won't be any Zearn lesson. I hope you guys are watching this, okay? But a lot of these topics are going to show up on that quiz. It'll be open notes, all right? It'll be everything we've discussed over the past 3 weeks. You'll have all week to study as well. We'll go over that a little bit off camera. Let's continue our lesson. Okay, it looks like our notes were correct. Triangle A is equilateral. Triangle BEF, BEF, that's isosceles because they have 2 equal sides. And our last one, no equal sides, are scalene. I want you guys to write those out because the spellings are a little bit tricky. So get used to practicing those. On top of your chart that you created, I would write those out just to make sure that you're used to the spellings.
We've been talking a whole lot about triangles today. What are some things we know about triangles that can help us draw one of our own?
All right, y'all. I don't know if you guys have a graph paper at your house. It's okay if you don't. If you want, you can use, you might be able to use line paper if you have notebook. If you don't, that's fine. You can maybe trace with your finger on your screen. That's totally fine too. But we're going to use the grid to draw a triangle, plot 3 points, and label them A, B, C. Connect the points with line segments to make a triangle. All right, I'm going to go ahead and try this out. Let's have some fun with this. I'm going to do A here. Let's call it A. Notice I plot my point first, then I name it. Let's do point B down here. Point B. I name it. And let's do C right here. Point C. I'm going to connect it with a different color. I'm going to try and be as straight as possible. If you have a ruler or a straight edge, that's always the best way to draw a line or a line segment between your points. Okay? Now, this is a little bit tough, but if I had to name this triangle, I would name it, let's see, let's look at our side lengths. So from A to B, so side AB is 1, 2, 3, it looks like 4 units. Side lengths B to C, let's do a C just like that, is 1, 2, 3 units. And then A to C is, it looks like it's a little bit longer than 4 units, okay? So we'll say it's about 5 units. I'm going to do A, C, and I'll do the approximation symbol here because it's not for sure 5 units that I can tell anyway. Maybe it is, but I haven't measured it. So I'm going to say it's approximately 5 units. So 3 different side lengths. That means it is a scalene triangle. Scalene triangle. All right, let's see what they come up with.
Lucas, show us what you got.
I drew 3 points and then connected them with line segments. It made a triangle. 3 sides, 3 angles.
I love it. I did something similar. I drew 3 points and connected them. Is mine a triangle too?
All right, I want you to answer this question. Did Mr. Sawicki draw a triangle? All right, I hope you answered it. I answered no, he did not draw a triangle. Why did Mr. Sawicki not draw a triangle? Go over to Google Classroom and explain in 1 sentence in a private message. I'll see you in a second. All right, you guys are back. And the reason Mr. Sawicki didn't draw that triangle was because that was just a straight line, all right? Even though it had 3 points, it was still a straight line. A triangle needs to have 3 sides, all right? That only had 1. And then it also needs to have 3 angles, 3 sides and 3 angles.
Mr. Sawicki, you just drew a line. A, B, and C are all on one line. They're already connected. A triangle has 3 points that aren't in a line, connected by 3 segments that make 3 angles. 2 of the points can be in a line like this, but not all 3.
Bam! You got it. Let's do one more.
All right, my friends. We're going to match the triangle with the correct label. I want you to do this on your own. What you're going to do is you're going to grab that triangle, make sure you click it, hold it, and then you can drag it to whatever the correct classification of it is. All right. Pause the video now. I want you to do this activity. Press enter, see if you're correct, and then check your work against mine. Okay, our first triangle here, it looks like it has 3 equal sides. I can tell because it has 3 tick marks. Let's go ahead and drag that to equilateral. That's an equilateral triangle. Our second triangle, 2 tick marks, and I can sort of tell that this side and this side are the same length. That also means that these are the same angle measurements, all right? That's for a different day, though. So this is an isosceles triangle. Again, say it with me, isosceles triangle. And last but not least, this has no tick marks. That means no sides are the same length. And I can sort of tell this is the shortest. This is pretty long, but I actually think our diagonal here is the longest. That's a scalene triangle. All right, we have our triangles classified. Let's press enter. Great job.
This triangle is scalene because each of its sides is a different length. Scalene triangles have no lines of symmetry. This one is an equilateral triangle. All 3 of its sides are the same length. Remember that it also has 3 lines of symmetry. And this is an isosceles triangle with 2 equal sides and 1 line of symmetry. Nice job today thinking about side lengths and symmetry in triangles. It's time to go show what you know in the Tower of Power.
All right, excellent work. Today we're going to head over to the Tower of Power. I want to do that with you. If you want to try it on your own, that's totally fine. I would watch part of this video, though, because on your exit ticket, not only are you going to have to categorize and classify triangles based on side length, but we're going to pull in some review from earlier in the unit. So you're also going to have to classify triangles based on their angle measurements, all right? That's obtuse, acute, and right. If you know those really well, that's fine. If you watch this video, you'll get a nice review. All right, my friends, let's get right into it. Our Tower of Power, independent practice here. All right, we have an equilateral, we have an isosceles, and we have a scalene category. Go ahead and drop these into the correct box and then press enter. We can check our work right afterwards. You can pause the video now. All right, our first triangle here, it looks like it has 2 equal side lengths, so that's an isosceles triangle. Our next triangle has 3 equal side lengths, so that is an equilateral triangle. And our third triangle has no equal side lengths, so that is a scalene triangle. Let's check our work. Excellent job. Let's keep climbing. Okay, the triangle has blank equal sides. Now, there are no tick marks here, so we can't use tick marks to help us classify this based on side length. But we do know that there are 3 lines of symmetry. Here's one, there's one right down the center, and then there's a third that cuts across this way, all right? So there's 3 lines of symmetry. Okay, now, what must this be? How many equal sides are there if there are 3 lines of symmetry? Go ahead and answer now. If you said the triangle has 3 equal sides, you are correct. If a triangle is equilateral, 3 equal sides, it will have 3 lines of symmetry. Nice work. Oh, real quick, before we go over this, how many lines of symmetry does an isosceles triangle have? Okay, I want you to think about that. Write it down, your answer. I'm going to tell you in a second. Let's see if you're correct. All right, an isosceles triangle has 1 line of symmetry, and it's usually right down the middle, from the top vertex right to the bottom, right to the base, center of the base. All right, classify by side length. So angle A is a what? And our choices are at the bottom here. You might have to scroll down a little bit. So angle A, 1, 2, 3, equal sides. Angle B, 1, 2, 3. Well, there's no tick marks here, so there are no equal sides. So that's a scalene. And so angle C, it looks like I have 1, 2 equal sides. That's an isosceles. Nice work, my friends. All right, I hope you lock those terms in, equilateral, isosceles, and scalene. We're going to jump right over to our exit ticket. I'm going to give you guys some tips and tricks and hints. I hope they're helpful. I'll see you in a second. All right, y'all. So we're looking at our exit ticket right now. Again, as always, make sure you're watching my videos and you're completing your Zearn lesson, the proper one, before you do this exit ticket. We are on exit ticket. We're Friday, May 1st. Exit tickets, module 4, lesson 13. So make sure you're done that lesson 13 on Zearn before you come over here. All right, the first few questions, in your own words, describe what an equilateral triangle is. How many lines of symmetry does an equilateral triangle have? Both questions were answered directly in your Zearn lesson. If you have to go back through my video or watch the math chat, I want you to do so. If you took notes, nice job. Hopefully you can go right off of those to answer this question. Question 2, same question, but in your own words, describe what a scalene triangle is. How many lines of symmetry does a scalene triangle have? You're answering both parts, okay? Make sure you're writing full sentences. And last but not least, in your own words, describe what an isosceles triangle is. How many lines of symmetry does an isosceles triangle have? All right, after that, we're going to get into question 4. These questions are all very similar, all right? We're going to classify each triangle by its side lengths and its angle measurements, all right? Side lengths and angle measurements. So we're going to have to select the correct names. So I'm always going to give you, so for 4 and 5, you'll have the same triangle, but you'll have different answer choices. So for 4, you'll have only side lengths, all right? So you're only describing side lengths here. All right. So is this triangle equilateral, isosceles, or scalene? Think about how many tick marks it has and how many sides are the same. Once you classify that based on side length, then we're going to classify it based on its angle measurement. Okay? So it can be acute, it can be a right triangle, or it can be an obtuse triangle. All right? Now, you know, based on, and I'll give you guys a little bit of a, I want you to focus on this before you focus on this triangle here. So when we're talking about an acute, and I answered this a little bit earlier in the video, but when we're talking about an acute triangle, we're talking about a triangle that has, all right, what I did really quickly was I created this diagram real quick that I think will be helpful, okay? So there's 2 ways to classify your triangles. We talked about doing it by side lengths, right? So you can have a triangle that it's got 2 different classifications. It's got its side length classification, that's one, and then it's got its angle measurement classification. So this is all angle measurements. So you know that a triangle is an acute triangle if all 3 sides are less than 90 degrees. If all 3 sides are less than 90 degrees, it's considered an acute triangle. If one side is greater than 90 degrees, if one angle is greater than 90 degrees, it's an obtuse angle. Remember, obtuse means it opens larger than 90 degrees. We can see that this is an obtuse angle, so we have an obtuse triangle. And here, if we have one right angle, okay, one angle equal to 90 degrees, that's considered a right triangle. So we can have our acute triangles, we can have our obtuse triangles, and we can have our right triangles. All right, all triangles have two classifications. You classify them based on length, and then you can classify them based on angle measurement. I would really pay attention to this. You might want to take notes on this page too, because it's very, very helpful for the next few questions. All right, let's classify this by its angle measurement. So we want to use this angle here. Is this an acute angle, a right angle, or an obtuse angle? I'll erase this for now because this won't help us. All right, let's go to the next question. All right, same thing here. Question 6, we're going to classify this triangle by its side lengths and angle measurements. We're going to start with side lengths. Let's look at our tick marks. Is this equilateral, isosceles, or scalene? And then do the same thing. We're going to classify it by its angle measurements. So take a look at its three angles. Are they all acute? Do we have a right angle, or do we have an obtuse angle? All right. What do we think? Is it an acute, obtuse, or a right angle? All right, go ahead and answer. All right, this one should be a little bit easier. We don't have any tick marks, and I can clearly see from my next question that I have my right angle symbol here. So how can we classify it based on side length? And then how can we classify it based on angle measurement? All right, last but not least, 10, classify the following triangle by its side lengths. Is it equilateral, isosceles, or scalene? And I need you to classify it by its angle measurement. So is it acute, right, and obtuse, or obtuse? You're going to describe your triangle classification in at least 2 sentences. So I want you to tell me, is it an equilateral isosceles triangle, right, or equilateral scalene? Is it scalene and right? It's got to have 2 classifications, one based on side lengths and the other based on angle measurement. Once you're done that, you are finished your exit ticket. Make sure that you're done your Dreambox work, and nice job this week. I'm very proud of y'all, and we will talk soon. Have a great one. I'll see you next time.